my name is Nuria. I will begin the road digital twin presentation, and then my colleague Balázs from Régens will explain in detail how the OMICRON platform works. In the OMICRON project framework, we have been working on the development of a digital twin that makes easier the operation and maintenance of the roads. The main objective of our solution have been improving the common solution of other digital twins in the current market that we consider that have disadvantages as lack of geographical context, abstract representation, no connection to data, and having different data sources. OMICRON platform is a tool that enhances maintenance and operation workers daily, allowing them to know the status of a facility or asset at a glance. Moreover, the operators can use the tool whether they are in field or at the office, due to the platform is accessible from any device with a browser and good internet connection. We consider it is a huge advantage that this platform doesn't need the installation of license of any specific software. In addition, key performance indicators show that the time to get information and real-time data from assets is significantly reduced compared to other solutions. This online tool, this OMICRON platform integrates the digital twin as well as the decision support system in a unique tool. In both of them, the digital twin and the DSS, a highway facility and its assets and data are represented to facilitate operators' daily work. Regarding the geographical context missed in other digital twin solutions, the approach in this platform to solve this issue have been creating a 2D map viewer with GIS technology. And the facility represented is the A2 road in Italy, where the final demonstrator took place. And the zone road is divided into stretches of 1 kilometer length between kilometer points. These assets are pavement and barriers. And when the worker selects each one of them, it is possible to see its data in the asset detail panel. In addition, features are represented as well in the 2D map through areas. And when the user selects a feature, a pop-up is displayed, showing its information as its identifier, the stretch that it belongs to, and its coordinates. This pop-up, as you can see, shows as well a button at the bottom where it is written CE beam. And when the user clicks in this button, is displayed the 3D of the feature. In this feature 3D viewer, created with BIM technology, the assets are represented in a realistic manner that allows the user to find any asset easily. This avoids the lack of geographical context and avoids as well the having an abstract representation. The obtaining of the data of the assets is carried out clicking in any of the 2D or 3D assets that conform the highway facility. This is achieved due to each asset contains its unique identifier to make the connection to the information of its physical or real twin. At the bottom of the slide, you can see 2 screenshots of the platform. In the screenshot on the left side, you can see a 3D viewer of a road stretch where a camera is located. And when the user selects the camera, the platform allows this user to watch in real time the video that specific camera is recording at that moment. And in the case of the screenshot of the right-hand side, there is represented another stretch of the same road where a weather station is located. And in this case, when the user selects the weather station, the data that the sensors of this device receive are shown in form of charts. Well, to finish from my side, because later we'll present Balázs, I would like to comment that the integration of all of the information of a facility in just one platform avoids the problem of having different data sources, what avoids misunderstood due to different versions of data. And I would like also to comment that this solution for operation and maintenance of a facility could be extrapolated to other kind of infrastructures as train tracks, campus, neighborhoods. I mean, with their features and assets. It would be necessary to study the kind of infrastructure to represent it and to integrate all the data in just one platform. Well, that's all from my slide. Now my colleague Balázs will present. Balázs,
Okay, thank you.
Balázs, you have only 4 minutes.
Okay, thank you, Nuria. We play a video presenting the application. You can start it.
Okay.
So, yeah. Is it started? Okay.
Yep.
So this is our OMICRON platform. In this video, I show you the platform's functionality. After login, you can access the platform features. You can select the specific highway you want to work with from a list of pre-registered highways. The interface consists of 2 main sections, the digital twin and the decision support system. Both sections have a similar structure, so each submenu opens into an information panel and a visual panel, as you can see. And by default, the visual panel displays a map, but it can also showcase BIM models, point cloud files, images, etc. You can also filter the assets by its type, and also you can navigate to the asset details, and you can also navigate it on the BIM model. And in the inspection submenu, previously recorded inspections can be viewed and edited, and can be filtered by various criteria. In the inspection details, you can select the inspection type, the date of the inspection, and the description. And on the Files tab, you can view any uploaded files such as videos, images, spreadsheets, or point cloud files. Inspection-related assets can be viewed and edited as well. And assets can be selected either from the asset list or from the BIM model. If you close the submenu, you can see everything in one view. And in the monitoring submenu, you can see real-time and historical data. And in the weather tab, you can see wind speed, air temperature, and humidity charts. And yes, and also live traffic camera, which is connected to the asset in the BIM model, and the bridge monitoring chart, which is in connection with the bridge health. The digital twin is integrated with the decision support system. And here you can see detailed information of payment conditions, with each segment on the map visualized. And in the bridges submenu delivers comprehensive dynamic identification, evolution, and damage detection data. Within the planning submenu, you can see the Gantt diagram sorry, it is planned, and yeah, and the maintenance interventions. Yeah, sorry, this was a little bit faster. Nuria, can you go backward a little bit to see?
Yeah.
Okay, for planning, maybe a little bit back. Yeah, so you can see the Gantt diagram, which is for planning the work zones, and you can see the traffic impact after this. So how much impact the whole work zones are in. And Nuria, can you play it? Sorry.
Yeah.
And yeah, the traffic impact at the KPI values. So the user can see this information, and the maintenance interventions is for the detailed information of each work zones. You can go to the next slide. And so the platform properly integrates the digital twin and the decision support system, and and the time finding an asset data can be reduced by more than 50%. And the operation and the maintenance decisions can be fully informed by real-time data, historical data, and static data. And as Nuria mentioned, it could be developed for other kind of infrastructures, but this platform is specifically for roads. And you can check out the platform with the link and the credentials below. And thank you very much.